Hello, Mr. Minnick, helping students in Python take a simple program that when we run this Python turtle graphic program and click in the button area, the screen turns green. And when we run the program and don't click in the button area, it doesn't turn green. So it's a simple button concept with if statements and loops and turtle graphics. But we're going to upgrade this and turn it into something interesting that's beyond this. So let's take a quick look to see how this works in the current version. Well, Julian here, for example, knows, Julian knows that you have to import turtle graphics and that you should always organize your code in a way that the screen is drawn first with any graphical elements that you want to draw on the screen. Like in this case, there's a turtle called button1. I used to call these pens. And by doing speed 0 and hide turtle, it just makes it go fast without some annoying icon. And if you move forward 100 pixels and you turn left, you know that if you do that 4 times, you know that you just drew a square. And turtles start at 0, 0. So that's why this is in the middle of the screen. But we're going to make it so that moves around to different locations. Well, to move a turtle, you could go in here and use the goto command, but it might be best to use a constant that's easily changeable. So anybody that is following me in this video and doesn't just want to wait for the version that they can copy and paste, maybe you have constants like button1 left edge. And maybe you make the button's constant equal to, oh, if we're going to be moving it around, it's not something that's a constant. So it's more of something that varies, also known as a variable. So let's just call this lowercase button1 left edge using camel case notation. And let's set it equal to 0 for now. And let's do button1 bottom edge. And let's set that also equal to 0 because I can't think of anything better. And let's just then do button1 goto wherever button1 left edge is, and button1 bottom edge. When I run this program, it's not going to work any differently, but it's much more upgradable. So see, the button still shows up here, but now somebody could change this to say negative 100. So will the button move left, right wise to the left or the right if I make its left edge negative 100 when it was originally 0? Hand? Anyone? Anyone? Bueller? Anyone? Great 1980s movie, but this is sadly 2019 and nobody knows the answer to this. Julian?
No.
Will this go to the left or the right because I now have the coordinate negative 100 in the number line rather than 0? Good answer, Julian. Let's see. Let's test his theory. It did. It moved over here, like when I ran the program. Hey, how could we make it move up also? What would its bottom edge is currently at 0 on the y-axis. What could be typed to make this bottom edge go up? What could be changed somewhere here to make it go up vertically? Anyone? I'm desperate. Ethan says make that the number 100. Let's test Ethan's theory. When I click run, this button should be up here more. It is, but I forgot the old pen up command. Okay, that's a little glitch. That's just annoying with turtle graphics. So you know what? The button's pen should have been pulled up off the paper before we did that. And then before we draw the button, we should put the pen down. So now I think this truly does work. So when we run this, it works. It's in the upper left corner. So this is a game that's fun only the first time you click run because you wouldn't know where it's going unless you knew where the coder. So let's make random numbers show up here. So every time you run the program, it's in a different location. So I'm going to temporarily disable that. Does anybody in this room of period 10 awesome 2019 students know how to create a random integer using the Python random imported class and the randint method that's available in Python turtle, in Python, not turtle, but just Python. Ethan again. Type what? Rand int, but you got to type random first, then random.rand int the way I taught it. Then two numbers need to go in the parentheses here. Can anybody give me good numbers that would keep it on the screen so it's not off the screen in the typical Python grid coordinate system? Negative 200, comma 200 would be two good numbers to use, but you could change that on your own time. And I will have another flaw. When I run this program, it crashes like, oh my gosh, crashes. But we forgot to import random according to this error message. So I don't have time to take hands on everything here, but there were, just for the record, a lot of people knew the answer to this. Either comma random or on a line all by itself, it's up to you. And a good coder that works in a place that makes like, well, good money and helps the world probably should explain in the hashtag comments why he or she imported random. Well, to use the rand int method. And turtle graphics, to use them, well, to have turtle graphics. That's why we import turtle. So now this program will put the button at a random location. Every time I run the program, it comes up in a different spot. See, I'm running the program and it's different every time. So you asked and I delivered how to upgrade a simple demo program that put a button in the middle of the screen to a random spot. I'm going to pause my video and ask period 10 if they have any other special code requests. Hey, we're back. And off video, Ethan said, could the size of that change each time we run the program, not just its location? Heck yeah. Right here, where if you trace the code carefully, you would see that that's where we move forward 100 pixels, then turn left like a soldier, and then march forward, turn left 90 degrees, then march, then turn left. And if you do that 4 times, you're a soldier who basically walked a big square somewhere in the marching field, and you're back to where you started. But we could change that 100 to a smaller size, or better yet, a random number that isn't always a 100. It could be a random size between, say, 50, where 50 is the smallest possible size, and let's just say 100 is the largest possible size. Let's go even smaller. It could be something as tiny as 10, with a square with a diameter of 10, not a radius, but a diameter, a width. So let's run that variation of the program. Now, every time I run the program, it doesn't quite work well. It's not. Oh, each time I roll, I get a different size for each side of it is a different. So let's use a variable called button1 width and set that equal to the random number. I know a lot of people would have figured this out on your own, but this video is kind of short. So button1 has a standard width that every time I run the program, that button will be used for each new button, but that width is being defined one time only right there. So now when I run the program, that's the size of it, but the next time I run the program, that's the size of it. The next time, only the random gods know what size it is each time I roll the dice. Unless the dice are fixed, in which case somebody cheated. So there's an upgrade. That was by special request. I'm going to go off video now to ask for any other special requests. So one more upgrade to squeeze in before the bell rings in this otherwise exciting period 10 class. I had a special request that each time it's a random color. Well, we all know that when you set up the screen and draw your button, a turtle graphic, a pen graphic can have a color. Now you could make the color whatever Julian's favorite color is. It looks like it's orange because he's playing some game right now that has an orange background. Just saying, this Julian right here. So I could do red. So proof of concept. Every time I run the program, yeah, it's red. But let's make it different every time. So instead of using red, I could use the fact that you can specify red, green, blue amounts, numbers between 0 and 255. The redness, let's make it like a high amount of redness, like 10. That's actually a high amount, 10. And a low amount of greenness, that'd be like a number close to 255, like 250. And a low amount of blueness, like 230. So this is going to be mostly red with just a little splash, I say, of greenness, and RGB. The B stands for blue, not brown. A little bit of blueness. This is going to be like mostly red. Okay, I don't understand color theory, so see our great art department at Why I Miss Things, I understand why that's cyanish or not, because it's not what I predicted. But anyway, let's just make it random. So give me a random number. I'm asking the dice that's between 0 and 255. That's the amount of redness. But I'm also going to throw in a random amount of greenness and a random amount of blueness. By rolling 3 dice at the moment of birth for that button, when I run the program, every time I run the program, not only do I get a randomly sized rectangle, square, it's randomly placed on the screen, and it's a random color. And let's do begin fill, end fill to make it filled in. So I once heard that if you draw a square with 4 sides to it, but you type begin fill at the beginning, in this case button 1.begin fill with an underscore in between begin and fill, and you don't forget to end fill outside of the loop at the end, like end fill, now every time I run this program, it's a random square and such, but it's filled in. And wow, it really makes a point now. Ooh, cool. But I had to click run. I wish there was a program that when I clicked on the button, it disappeared and a new button showed up. Oh, that's the game called Bubble Pop that I invented. So by taking this and merging it in with some other demos, you could get a very fun game that might even add up the score as it goes. But I'm going to stop there. That's enough fun for this video. This is the 2019 period 10 off picnic contributed dish to the covered dish picnic. And this is what they brought to eat. Guacamole dip would go over well with this. I think this kind of chip, Tostitos, goes well with guacamole dip. Okay, I think it still works. I might freshen this up a little bit, but the video will be aligned soon and for the rest of my teaching career. Have a great day.